Hello everyone and welcome to our next demo of Ionir Kubernetes Native Storage. My name is Barak and I will walk you through this demonstration. In this video, we will review how using Ionir storage system protects any Kubernetes stateful workload from an unplanned node shutdown. Out of the box. Let's start the demo. This is Ionir's cloud dashboard. As you can see, we have a cluster called HA cluster. This is our Kubernetes cluster for this demo. We have 3 worker nodes set up in this cluster, and 1 workload deployed, which is our Postgres statefulset we have prepared for this demo. The last piece is the storage footprint and deduplication ratio information. Let's click on the cluster to see the workload mentioned. We select the Postgres demo workload. As you can see, this workload is a persistent volume allocated with a size of 50 GB using Ionir Postgres storage class. This is of course thinly provisioned, compressed, and deduplicated. Let's start the demo and crash a node to see what happens. Let's first watch the status of our Postgres pod on the middle window and make sure everything is running. We are good to go. Now let's watch the cluster node status. We can see that the 3 worker nodes and the master node in the cluster are all running and in ready status. Now let's connect with our Postgres DB and run some queries. Let's examine the DB size. We can see that it's approximately 1.5 GB. Next thing, let's count the rows. We have exactly 10 million rows in the database. Lastly, let's run a quick query to see some content from the database. Perfect, we are all set to go. We can see that the Postgres pod is running on this node, and we can find its external IP from here. Now let's SSH to the node to simulate our crash. A simple and quick sudo reboot will do the trick. After a few seconds, we can see that the node is reporting a status of not ready. The pod, of course, cannot report back the right status since it's unknown. This is a typical Kubernetes behavior, and it has a predefined timeout values. Let's try to force kill a pod to make things interesting. Ionir has a built-in corruption protection mechanism that prevents the pod from starting for about 2 minutes, allowing enough time to securely identify the node failure. This is why the pod appears to be stuck. Let's kill the pod again just about after 100 seconds. This time the Postgres pod is scheduled on another node and connects to its PVC. After a few seconds, it is up and running. Let's quickly run an SQL query against the database. And we get the same result just as before. The Postgres DB is up and running as expected. Going back to the dashboard, we can see Ionir's system detected the node failure and notifies the user of data redundancy issue. This, of course, will be solved when the node comes back online. We can also see that the workloads and the volumes are all available for operations without any impact. Thank you very much for watching this quick video. You saw how Ionir highly available storage protects any persistent data from unplanned system downtime. This is relevant, of course, for planned downtime as well. Thank you very much again, and if you're interested in getting more information, please visit our website at www.ionir.com. Goodbye.